Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to look at a third method of finding the volume of a solid by rotating an area around either the x, the y, or any other axes. Okay, so this method is called the method of shells. Remember, so far we did the method of disks and the method of washers. Now, this is called the method of shells. And some people call it the method of cylinders. And as usual, it might be just easy to illustrate that through a couple of examples. Maybe in one time we are going to take a function and rotate it about the x, another about the y. So let's see how we do that. Suppose here I have f of x equals 1 over x. I want to rotate about the y, and my x value is between 1 and whatever, 7, anything. It's really not that important, any two numbers. Okay, so I know that 1 over x has two branches, one in the first quadrant, one in the third quadrant. But since x is positive, we are in the first quadrant. There is no reason to draw the branch in the third quadrant here. I know that the function would look something like that. It's asymptotic with both the x and the y, 1 over x. And we want to rotate it between x equals 1 and x equals 7. We are used to it when what we learned is that if I want to rotate that about the y-axis, I will pretty much take a horizontal strip and use the method of washers. I will have an outer disk and an inner hole. I subtract this from that. So it's a lot of work. And you say, so how can I do it differently? I say, okay, take a vertical. Notice that in the disk and the washer, if I'm rotating out the x, I take a vertical strip of width dx. If I want to rotate about the y, I take a horizontal strip of width dy. But in this case, I'm going to take a vertical strip of width dx, even though I'm rotating about the y. Why? Good question. When I rotate this about the y, what will I generate? I will generate a cylinder. Look at that. A cylinder that has a width of dx. So there is a thickness here of dx. The height is basically f of x, which is 1 over x, right? But what is the circumference of the base? Because I know that the volume of this cylinder is the circumference of the base times the height times the thickness. Some people would say, yeah, so that's it. But some people would say, you know what? Sometimes we can make it easier by splitting it from here, for example, and spread it open. It will give me a rectangular prism. That rectangular prism has a thickness of dx, yes, has a height of f of x, yes, and what is the base, the length of the base? It is the circumference of this circle. That's why we multiply the circumference of the circle. Well, again, you don't need to draw that, we're just doing it here. Just so this thing is 2 pi x because the radius is x, right? 2 pi x. And the height is f of x, and the thickness is dx. So this small element has a volume dv equals to 2 pi, which is a constant, x times the height, which is 1 over x dx. And you can see the x and 1 over x cancel each other, and you get 2 pi dx. That's how simple it is. So now if I integrate that to get the volume, 2 pi is a constant, and I'm integrating from 1 to 7 dx, which I get 2 pi times x evaluated from 1 to 7. So it's 2 pi 7 minus 1, which is 6 times 2. It's 12 pi cubic units. Very simple, much simpler than the washer where I had to get an outer disk and an inner hole and subtract this from that after squaring. No need to do that. Okay, so that's how we do it if we want to rotate about the y-axis. Let's take another example where we are rotating about the x-axis. So let's say I have a function, and this function is g of x equals the cube root of x. And I want to rotate about the x-axis, and my x values are from, we need a cube, so a cube root of an integer, so we end up with an integer number. So let's say 0 and 8, or 1 and 8, since one cube is 1. It's the same thing. Let's first plot that or graph it. So here is my x, here is my y, and here is my function cube root of x, g of x equals cube root of x. Here is the 0. I made it 0 so it's easier because I don't need to subtract the lower limit, okay? Here is the piece that I want to rotate about the x-axis. Notice in this method, we take a horizontal strip, so parallel to where I am rotating. See, we took a vertical strip when we were rotating about the y. We are going to take a New York strip. No, I'm sorry, I'm hungry. Just making fun. Okay, I know it's a bad joke. Don't worry about it. Okay, so I'm going to take a horizontal, not a New York strip. Medium well. And I'm going to say, okay, I'm going to rotate this thing about the x-axis. So the height, which would become the radius. Remember, the width here became the radius of the base. The height here, y, would become the radius of this horizontal pipe or cylinder that will be generated. The thickness is dy, the height is y, but this thing is expressed in x. So I have to rewrite it. Here, this thing tells me y equals cube root of x. So what I'm going to do is to take the cube of both sides, right? So I get x equals y cubed. Okay. So now that width becomes 8 minus y cubed, meaning that would become the height of the cylinder that is made sideways, right? The cylinder would look something like that. So this length is y cubed minus 8. The height would be 2y because that's the radius. Notice this is the radius. There is another y is y. And the thickness, of course, is dy. dy. So my element has a volume of 2 pi y times the height, which is y cubed minus 8, times the thickness, which is dy. You don't have to leave anything, right? But if I'm integrating, if x goes from 0 to 8, and I'm integrating with respect to y, if x is 8, then you take the cube root, the opposite of what we did here, and that gives you y equals 2. So my integral now becomes 2 pi is a constant. I'm taking the integral from 0 to 2 of y to the fourth minus 8y dy. That's why I picked a number that has an integer cube root. I mean, it doesn't matter if you are going to do that on a calculator or something, or even evaluating it with radicals or decimals. It's not a big deal. So I'm going to get 2 pi times y to the fifth over 5 minus 4y squared, right? From 0 to 2. That's why I told you I picked 0, not 1, so I don't have to subtract. It's just substitute with 2. So I get 2 pi times 2 to the fifth is 32 over 5 minus, and 2 squared is 4 times 4. What happened? What did I do wrong? We took the integral of 8. Oh, it's 8 minus y. Why did I write y cubed minus 8? It's 8. I'm sorry. That's backwards. Woo. So that's negative, that's positive. I apologize, guys. So this is negative, this is positive, because otherwise the volume would be negative. I said something doesn't add up, right? Okay, so I don't know. See, when I said New York strip, I told you I'm hungry. I got everything backwards. Okay, maybe I should redo this video, right? You will hate me if I keep it. But anyway, let's see. So 16 is 80 over 5, right? So I get 2 pi times 80 over 5 minus 32 over 5, which is 2 pi times, or 2 pi over 5, and this is 48. 48 times 2 is 96 pi over 5 cubic units. Yeah, please accept my apologies. If there is anything in this method that is not clear, please let me know by leaving a comment in the comment sections, and I will get back to you as soon as I can. Next time, I promised you, there is a surprise for you. Something that relates to what we did with in the engineering course of statics, where we were finding the centroids of composite shapes. We'll talk about that and how it relates to what we did so far. So keep watching. Thank you very much for your time. Hope to see you soon.